Hello children, welcome back to my channel. I am now doing 10th class maths. A new chapter I am starting, that is tangents and secants to a circle. So first you should have a knowledge about what is the meaning of these two terms, that is tangents and secants. So if you draw a circle, suppose this is a circle with center O. If you draw a line which is intersecting the circle at only one point P. This is called as tangent. Otherwise, if you draw a line which is intersecting the 2 points at Q and R, then this is called as a secant. This you should know, children. So, what is the definition of a tangent? A tangent, a line which intersects the given circle at only one point is called tangent. This you can write as a definition of a tangent. When it intersects the given circle at only one point. And what is secant? A line which intersects the circle at 2 points. It intersects the circle at 2 points. And here, the line which intersects the given circle at only one point is called tangent, and the point is called the point of contact. Point of contact. This point has got a specific name P. This P is called point of contact. So this is a small introduction about tangents and secants, children. Please note it down. I'll proceed with the do these sums. Do these sums, children. The first one, draw a circle with any radius and draw 4 tangents at different points. So children, first suppose we have drawn a circle like this. This is the center. And they are asking to draw tangents at 4 different points. So I am taking one point here, P. This is Q. This is R. This is S. So they are asking to draw tangents. Tangents means what? It should pass through only this point. So through P1 and through Q1, through R1, through S1. So these are the tangents that I have drawn. This is 1, this is 2, this is 3, this is 4. Now the question is, draw 4 tangents at different points. How many tangents, more tangents you can draw? See children, if you talk about a circle, how do you define a circle? A circle is a closed figure which is formed by infinite number of points. So a circle has infinite points. So sorry children, when you are able to draw the tangents from 4 different points on a circle, from each point you can draw a circle. So therefore, number of tangents that can be drawn, to a circle are infinite. We cannot count. We can draw this many, because through every point you can draw the tangent. So infinite number of tangents you can draw. Then second bit, how many tangents can you draw to a circle from a point away from it? So suppose you have got a circle like this. Oh, and there is a point P. From it, how many tangents you can draw? You can draw one tangent like this, and you can draw another tangent. More than this, you cannot draw. So through a point which is outside, we can draw only two tangents, not more than that. You can draw only two tangents from it. Now the third one is, in the given figure, which lines are tangents to the circle? This is the figure given in your textbook. You have got L, M, P, Q lines are given. So I have already explained you what is a secant and what is a tangent. Tangent should pass through the circle through only one point. So here P and M, these are the two ones which are passing through the circle at only one point. This is the point of contact here. This is the point of contact here. So we can say that lines P and M are tangents. Only these two are tangents. The remaining two are considered as secants. Please note it down. Do this, some children. Draw a circle and a secant PQ to the circle. So let me draw a circle O. And secant means the line which is intersecting it at 2 points. So let me consider this. This is P and Q, 2 points. Then the next one, draw various lines parallel to the secant on both the sides. Means on this side as well as on this side, I should draw the parallel lines. So let me draw. This is one and this is two. These are parallel to the secant. Similarly, on the other side also, you have to draw the lines parallel. See children, this is not construction, so directly I am doing. When you are drawing constructional parallel lines with the instruments only, we have to do. So draw various lines parallel to the secant on both the sides. So this is what the solution that is given here. Next, what happened to the length of the chord coming closer and closer to the center? See, this is the center and PQ. This is one chord. PQ is a chord. This is a chord. Chord means what, children? First of all, you should understand what is the meaning of a chord. If this is a circle, this is the center, this is called as a chord. It is only a line segment which is drawn by joining any 2 points of a circle. That is a chord. Already you have studied in previous class. Just as a recollection, I am explaining you. So this is called as a chord. Now the question is, what happened to the length of the chord coming closer and closer to the center? See, if you see the length of the chord which is coming closer to the circle, is it not increasing? So when the length of the chord coming closer to the closure, so length of the chord increases as it comes closer and closure to the circle. So definitely the length of the chord increases. Now the next question, what is the longest chord? Longest chord means this, children. This is also a chord which is passing through the center. What is the longest chord? Longest chord is the diameter. Yes or no? Because the diameter is the one which is passing through the center of the circle. So that is also called as a chord because it is passing through the circle, means it is intersecting 2 points of a circle. So definitely it is a chord. So the longest chord is nothing but the diameter. Next, how many tangents can you draw to circle which are parallel to each other? Suppose you have got a circle like this, children. This is O. You have got a point here P and you have got a tangent like this. Okay. Now to this, how many parallel tangents you can draw? You have to draw only one here. So how many tangents can you draw to circle which are parallel? We can only draw two. We can draw two tangents. Two tangents which are parallel to each other. We can draw only two circles which are parallel to each other. Please note it down, children. This is another do this sum that is given in your textbook. Now theorem, children. This is theorem 9.1. What does this say? Tangent. The tangent at any point of a circle is perpendicular to the radius through the point of contact. So a circle is given to you. This is a center and let me consider this as a tangent. And P is the point of contact. So what is given to us? We have got a circle with center O. And let me write L. L, line L is the tangent. This is also given to you. And P is the point of contact. This is given to you. Now what is RTP required to prove? You have to prove that tangent to any point of a circle is perpendicular to the radius. So OP is radius and P is the point of contact, and let me write even that. OP is the radius. OP is the radius. Even that is given here. Now what is RTP? RTP is OP is perpendicular to line L. You should prove that OP is perpendicular to line L. Now there is a construction here, children. What is the construction? Construction is you have to locate a point Q on the tangent. First point is locate a point Q on the tangent. Okay, this is first one. And what is the second one? Join OQ. So I need to join OQ. So construction should be drawn in broken line. So I have drawn like this. So join OQ. So now let me see about the proof, children. What is the proof? See children, when you are talking about point P and point Q, Q is lying outside the circle, P is on the circle. So Q lies, point Q lies outside the circle. Since point Q lies outside the circle, we can say that OQ is greater than OP. Why is it? Because this is radius of a circle. When it is outside the circle, it should cross the circle and go out. So definitely OQ is greater. That means what? You take any point on the tangent which is not P, except P. We know that a line is a combination, or it is a set of infinite number of points. That is the definition of a line which you have learnt. A line means what? Infinite number of points joined together, you are getting a line. So in this case, when you are talking about this tangent is having infinite number of points. But in that infinite number of points, it is only point P which is in contact with the circle, which is intersecting the circle. But do you have any other point which is upon the circle? Definitely no, because only one point. This is a tangent, means tangent definition itself, the tangent intersects the circle at only one point. That means what? Any other point on the line, this line L is away from the circle. As an example, we are taking only one point Q, but this explanation belongs to each and every point on L except P. So that means what? When OQ is greater than OP, that means what? What you can say? OP is the shortest line segment drawn from O to L. Isn't it? OP is the shortest line segment drawn from point O to line L. That means what? We know that. See children, in your previous class, you have got an explanation, a theorem for it, that if you take a line, here I am explaining, I am not supposed to do that here. So here I am explaining you. Suppose you have got a point P here. From this point P, if you draw innumerable number of line segments like this, if you draw any number of line segments, the shortest one is always perpendicular. This is what you have done in your previous class. Once again, as a recollection, I am saying, from point P, if you draw various lines, the shortest one is perpendicular. So here, when we have said that OP is the shortest line segment to O, therefore, we will be saying that OP is perpendicular to L. Hence, proved. This is how you have proved this statement, children. I hope I am clear. Please note it down. Theorem 9.1. Now, the next one is construction, children. The construction is construct a tangent to a circle at a given point on it when the center of the circle is known. So, suppose this is a circle with a center O and P is a point. Now, the question is, you need to construct a tangent to a given point. So, first what you have to do, you join OP. After joining OP, you know that tangent is always perpendicular to radius. That is what we have learnt in the previous problem. So here, let us extend it. as a line. Now what you have to do? You have to draw a perpendicular. How can you do perpendicular line? You can draw in two ways, children. One is by using compass and another one is by using this protractor. I am using protractor and I am doing it. So here at P, if you keep the point, 90 degrees is here. So let me draw a line. So this is the tangent. I can name it as x and y is the tangent drawn to a circle. How do you know? Because it is perpendicular. So what are the steps of construction? Steps of construction. First one, first you have to draw a circle with center O. First you draw the circle with any radius. Second one, locate a point P on the circle. And the third point is join OP and extend it. You have to extend so that you can you can draw a perpendicular. Fourth one, draw XY line perpendicular to OP. Then fifth point is XY is the tangent to the given circle. So this is the construction, children. Please note it down. Now try this some, children, but this is also very important one. This is, they are asking to draw a tangent to a circle whose center is not known. This is, suppose this is a circle, this is a circle, children. So to this circle, you need to draw a tangent where center is not known. So first what you have to do, take a point P upon it and you draw a secant. PQ is a secant. And from here, you draw R, PQR. And then what you need to do is, you have to measure what is this PQ, angle PQR. What is this measure? You need to measure it. So, I'll try to measure with it. Figure is small. And where is this point? I'll extend it to children so that I can understand where this line is. Because my instrument is very big. It's only for my convenience. You need not do. Your instrument is small only. So in the book you can do very easily. But since I wanted the angle, this is 60 degrees, children. This line is 60 degrees. So I have drawn measuring 60 degrees I have done. Now what you have to do is, you need to join R and P. These 2 points you have to join. After joining this is R and P. What you have to do is, this is 60 degrees, no? So the same 60 degrees angle, you have to draw it here. That means here 60 degrees you have to draw. So like this you have to keep your protractor, and 60 degrees I am getting it here. So if you use the instruments, you will get exactly, children. Now what you have to do, you have to join and draw like this. Then definitely it will be a tangent, because this angle is 60 degrees, this is also 60 degrees. So we will be saying that this is the tangent to the circle. Now let us write the steps. First, draw a circle, and second point, locate a point P on the circle, and the third point, draw PQ line segment. What is it? It is the secant. Fourth one, draw angle PQR and measure. It. Afterwards, join R and P. And sixth point, draw line L through PQ, through P, so that let me take angle RPL, so that angle RP, let me write S. Angle RPS is equal to angle PQR, where S lies on L, because S is another point I have taken. I should mention it. S lies on L. So seventh point, L is the tangent to the circle. This is how you say, children, but you need to give your proof. Is it really tangent or not? Now let me write the proof. See, children, you are getting PQR. In this is 60 degrees. These two are 60 and 60. So we need to prove that this is 30 degrees. How will you prove? Now let us see the proof, children. Now in this proof, we will be saying that angle PQR is equal to angle RPS. What are they? They are angles in the alternate segments. Angles in the alternate segments. What are alternate segments means, children? This is a chord. This chord is dividing the circle into minor segment and major segment. This is angle in the major segment and this is angle in the minor segment. So we have done this kind of angles in the alternate segments. Alternate segment theorem, you have got it in your previous class. According to the alternate segment theorem, if alternate segments, angles in the alternate segments are equal, then definitely this will be the diameter. We will be saying that therefore PQ is the diameter basing on alternate segment theorem. So if PQ, sorry children, if PQ is the diameter, then we will be saying that angle RQ is equal to 90 degrees because it is angle in the semicircle. Angle in the semicircle. Angle in the semicircle is always 90 degrees. So we know that in triangle PQR, angle P plus angle Q plus angle R is equal to 180 degrees. We don't know angle P plus angle Q is 60 degrees plus angle R is 90 degrees is 180 degrees. That means angle P plus 150 degrees is 180 degrees. So what is angle P? Is 180 minus 150, that is 30 degrees. That means this angle is 30 degrees. If this angle is 30 degrees, we will be saying that 60 plus 30, 90 degrees, isn't it? Therefore, angle QPS is equal to 60 plus 30, 90 degrees. Therefore, QP is perpendicular to line L. Therefore, L is a tangent. L is a tangent. So, in this way, you can prove, children. Even you can say that PQ is the diameter, means definitely diameter is perpendicular, means radius is perpendicular. Even in that way you can say, but in clear way if you want, you can do it like this, children. Anyway, the proof will tell you that this is the construction that we have done. This is the tangent to a circle where center is not known. Example, some children. Find the length of a tangent to a circle with center O and radius 6 centimeters from a point P such that OP is 10 centimeters. You have got a circle with center O and radius OP, let me call this OP radius. Radius is 6 centimeters and radius of the circle is 6, and the radius is 6. From a point P such that, sorry children, this is radius. Let me take a radius of a circle is 6 centimeters and there is a point P here which is 10 centimeters away. This whole distance is 10 centimeters. So let me write a radius somewhere here. Even this can be written as, this can be taken as OQ is the radius, that is 6 centimeters. Figure you can draw like this. OQ is the radius. OQ is the radius and OP is, P is a point which is 10 centimeters away from it. Now we need to find out the length of the tangent. So definitely this will be the tangent. Okay. Now we need to find out the length of the tangent. That is, we need to find out OP. So what is, you have got here given a circle with center O. OQ is the radius and OQ is equal to 6 centimeters and OP is equal to 10 centimeters and PQ is the tangent. Now we need to find out what is the measure of PQ. Now see, in we need not write this. Now let us see, PQ is the tangent. Therefore, OQ is perpendicular to PQ. Basing on the theorem, we have learned OQ is perpendicular to PQ. So, in triangle OPQ, we can say this becomes the tangent. This is opposite side of the right angle. What do you call this? Hypotenuse. OP is the hypotenuse. So, OP square is equal to OQ square plus PQ square. So what you want? You want PQ. PQ square is equal to OP square minus OQ square. So what is OP? OP is 10. 10 square minus what is OQ? 6 square. This is in the form of A square minus B square, that is A plus B into A minus B. So how much are you getting? PQ square is equal to 10 plus 6, 16 into 4. So what is PQ? Root of 16 into 4. That is root of 16 can be written as 4 into 4 into 4. So this, instead of 2 4s, I can take 1 4 out. Root of 4 is 2, that is 8. Therefore, PQ is equal to 8 centimeters. This is the answer, children. So you can do it in any way. 16 fours are, if you take 64, 8 8s are 64, so root 8. Anyway, you can do, children. I have just taken the factors and I wrote it in this way. Anyway, you can do. So this is the answer, children. Please note it down. This is example sum.